Welcome to Manavananban YouTube channel. Today let us see about Pythagoras theorem. So first let us see the statement of this theorem. So in a right angle, I write the statement here. In a right angled triangle, the square of the hypotenuse, the square of the hypotenuse is equal to is equal to the sum of squares of other two sides. The sum of squares of other two sides. Now let me explain the meaning for this statement. So if you have a triangle like this, I draw a triangle and I name the corners of the triangle. I name the corners of the triangle as A, B and C. So here the hypotenuse is nothing but BC. So BC is for the hypotenuse of this triangle, and then AB comma AC are the sides. AB and AC are the sides. Now if you say according to this theorem, so when you say BC is the hypotenuse, so we can say BC square is equal to BA square plus AC square. So this is according to the given theorem. So here we need to prove this one. So hypotenuse square is equal to sum of the side square. That is what the theorem says, and we need to prove this one. Let us see how to prove this statement. Now again I draw the triangle here. So here for my convenience I just flip this triangle. Now I draw a line. I draw a line like this. And let the line meet the center of the given triangle. Now name this corners. I name the corners. I name the corners as A, B and C. Now I name this point as D. Now we can say, so a triangle ABC is given, so it is right angled. So here if you take this triangle, so the right angle is at B, right angle is at B. So according to the theorem we need to prove that AB square plus BC square is equal to AC square. That is what the statement to be proved. So here B is what as a right angle. So I draw So here I have taken a line, so BD. Now I have two set of triangles. So first triangle is I separately I draw the triangle, then you can easily understand. So here I name the triangle, I name the corners. Here it is A, B and C. This is one triangle. Now another triangle I take. So here this triangle is set B. Now here you can see D is also at a right angle. So I draw like this. I take a triangle. Now I take AD as base. Here I take AD as base. AD as base. Therefore, the next point will be B. So this is for triangle ABC, and here this is for triangle ADB. I take two triangles here, triangle ABC and triangle ADB. So here from the two triangles we can say angle A are same. For both the triangles, angle A is common. Therefore, angle A is equal to angle A common. And then when you see angle ABC, so here angle ABC, so this is 90 degree. So here this is what 90 degree. Therefore, we can say angle ABC is equal to angle ADB. Angle ABC is equal to angle ADB. Therefore, from these two, uh, we can say triangle ABC is similar to triangle ADB. So we can see the sides. So from the similarity, we can write AB. So here AB. So from the triangle 1, I take this as triangle 1 and triangle 2. So from the triangle 1 and 2, I can write AB by AD. So base of the two triangles. AB by AD is equal to AC by AB. AC by AB. So ratio of the base is equal to ratio of the hypotenuse. Ratio of the base is equal to ratio of the hypotenuse. Therefore, AB square is equal to AC into AD. AB square is equal to AC into AD. So this is one equation. I take this as equation number 1. Similarly, we can take other two triangles. So we take triangle ABC and triangle BDC. Now I take triangle. I draw the triangle here. Triangle ABC. Once again I take triangle ABC. So A, B and C. And then I draw the triangle. So here I take BDC. So B, D and C. From the first triangle, you see here BD and C. So here BD is for the base, BD is the base, DC is on one side and BC is for the hypotenuse. So here you can see here also D is what at right angle. So I take BD as the base. BD as the base. So here we can see for the triangle ABC, right angle is what B. But for the triangle BDC, so here this is one angle, not a right angle. Now I have taken these two triangles, so ABC and BDC. Now you can see here, so here angle C is common. Angle C is common. So angle C is equal to angle C. And then triangle ABC. Here we take triangle ABC is equal to, that is angle ABC is equal to angle BDC. Angle BDC. So here these two angles are right angles. Therefore, triangle ABC is similar to triangle BDC. So from this, by using the proportionality, we can write. So we take the sides BC and DC. So here I take the sides BC and DC, and then the hypotenuse AC and BC. Therefore, the sides are BC by DC is equal to AC by BC. AC by BC. Now I get BC square is equal to AC into DC. I take this is equation number 2. Equation number 2. Now what I do, I add equation number 1 and equation number 2. What I do, I add these two equations, equation number 1 and 2. So equation number 1 plus equation number 2. So what is the left hand side? The left hand side is AB square plus BC square. Then what is the right hand side? Right hand side is AC dot AD plus AC dot DC. Now AB square plus BC square is equal to, I take AC as common. So inside the bracket I will get AD plus AC. AD plus AC. Now from the primary triangle. So here we have the primary triangle. You can see what is AD plus DC. So AD, yes, it is AD plus DC. Correct. AD plus AC is common. Therefore, I get AD plus DC. So here from the primary triangle, AD plus DC is nothing but AC. Therefore, I can write this equation as AB square plus BC square is equal to AC into AC. Therefore, AB square plus BC square is equal to AC square. So what is AC? It is what? The hypotenuse. So hypotenuse square is equal to what is AB? It is one of the side. What is BC? It is another side. So square of the sides. Therefore hypotenuse square is equal to sum of square of its sides. Correct. So AC square is equal to AB square plus BC square. In this way we can prove the theorem. Thank you.